Okay, so this video is about structural isomerism and branch chain isomers. So structural isomerism is when you have the same molecular formula, so same number of carbon and hydrogens with a different spatial arrangement of the atoms. So some examples that we will have seen are with the alkenes. So we have but-1-ene, okay, and then but-2-ene, and so we've moved the position of the double bond, okay. Some more examples of structural isomerism. We have propanol, and we can put the hydroxyl group on the second carbon in the chain, so that would be propan-2-ol, or we could put it on the first carbon in the chain, and we have propan-1-ol. So these are what we called positional isomers because we move the functional group. But what we're talking about today is isomerism in alkanes. Now, alkanes don't have a functional group that you can move the position of. However, what you can do is what I've highlighted is the methyl group, that's CH3. So we can move the position of this methyl group. So this is hexane, and we can add it, we can shorten the chain and add it to different carbons along the chain. So if you like, you could pause the video and practice that and put the methyl group in different positions, okay? Okay, so I will show you now where we can put this methyl group. So initially you might think, well, I'll just move it till the other end, okay? Well, if you do that, you still have a straight chain hydrocarbon, and it will still have six carbons in the chain. Okay, so that's still hexane. However, what we can do is shorten the chain. Okay, so here we have 2-methyl pentane, and I've put the methyl on the second carbon. Okay, so this is a branch chain alkane, and it's an isomer of hexane. Where else can I put this methyl group? Well, I can put it on the third carbon in the chain, okay? And then it becomes 3-methyl pentane. Now you might think I can put that methyl group on the fourth carbon, okay? But if we use the numbering system, we always want to use the lowest number. And so we can just switch the numbers around, and that would become 1, 2. Okay, so hexane, we can shorten it to pentane to form isomers, and the two isomers would be 2-methyl pentane and 3-methyl pentane. Okay, we can remove 2 methyl groups from the hexane. Okay, and that means that the shortest chain will be, also the longest chain will be 4 carbons. So it will become butane, and we can put those methyl groups in different positions. So here I have put a methyl group on the second carbon and a methyl group on the third carbon to form 2,3-di, that means 2-dimethyl butane. Okay. Now, another thing that we can also do to make a branch chain isomer is I can make an ethyl group. So that means that I have CH2, CH3. Okay, so now we add the carbon to this position, the ethyl group here, and I have 2-ethyl butane. To end the video, okay, I am going to draw an isomer, and I want you to identify the longest chain, the branch that is attached, and you could attempt to name that branch. Okay. So there's A. Okay, so I want you to So find the longest chain of carbons, okay? And then I'm going to identify the branch that is attached and have a go at naming it. Okay, and there's another one that you can have a go at naming. So if you pause the video, I will help you with that now. So if we look at A, okay, we've got 1, 2, 3. So this is propane. This will be a methyl group, okay, and it will be 2-methyl propane. You don't actually need that 2 there because we can't put the methyl group in any other position, okay. Let's name B. So we have 1, 2, 3, 4, 5, 6, 7. Okay, so the longest chain there is 7, and that will be heptane. Okay, and then the group that is attached, that's 1, 2 carbons, so that's an ethyl group, and it's on the 3rd carbon. Have I got the lowest numbering system? Okay, let's check, because if I did it from here, 1, 2, 3, 4, 5. Okay, so yes, that is the correct name, 3-ethyl heptane.